Hello again. We are continuing our discussion by talking about derivatives and specific rules about those derivatives. We're going to start with the simplest of rules about derivatives, or what we call differentiation. So let's get started. First, we're going to talk about something called the power rule. Now, in the last lesson, we learned that the derivative of x squared is 2x. In other words, if f of x is x squared, then f prime of x is 2x. But what I want to know is, in general, if I have a function that is x to any exponent, what would the rule be for the derivative of that function? So let's go back to the definition of what the derivative is. F prime of x is defined as the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so if f of x is then x to the n, it'd be really nice if I could figure out what that f of x plus h part is. Okay, well, f of x plus h is going to be x plus h all to the n. And remember, when you have a binomial raised to an exponent, we can use binomial expansion to figure out what that is. So x plus h to the n is going to be x to the n plus n choose 1 times x to the n minus 1 times h plus n choose 2 times x to the n minus 2 times h squared, and so on until the very last term is just h to the n. All right, so now I'm ready to plug everything into the definition of the derivative. So there's my definition, and then I plug stuff in. So it's the limit as h approaches 0 of that binomial expansion that we talked about, minus x to the n all over h. And what you'll notice is I've got an x to the n at the beginning and a minus x to the n at the end, and those can subtract out. Then what I'm left with is a bunch of terms that all have h's in them. As you can see, I've still got the n choose 1 times x to the n minus 1 times h. I've still got all those terms, and they can all individually be divided by h. So that's exactly what I'm going to do. That means that the first term, n choose 1 is simply n, so I'll simplify that one. But every term after that has at least an h in it. So I want you to keep that in mind, because this is the step where we set h equal to 0. This is the first time that we're able to set h equal to 0 without getting 0 over 0, so that's what I'm going to do. Well, the only term that doesn't have h in it being multiplied is the very first one. So that's the only one that's going to still be there. Everything else is going to become 0 as h becomes 0 itself. So that means that my answer is n times x to the n minus 1. So the derivative of x to some exponent is going to be that exponent times x to an exponent that is 1 less than the original. Okay, so let's look at some examples of that just to see what that looks like. If my function is x to the 8, then the derivative of that, f prime, is going to be 8 times x to the 7. Okay, so you always reduce the new exponent by 1, and that becomes your exponent in your answer. So if I have x to the 35, then the derivative will be 35 times x to the 34. If I have x to the 2.6, the derivative of that will be 2.6 times x to the 1.6. If I have x to the negative 4, then the derivative of that will be negative 4 times x to the negative 5. And it even works for fractions. If I have x to the 3/4, then the derivative of that will be 3/4 times x to the negative 1/4. Okay? So that only applies when you have x raised to an exponent. There are other rules. Here's another one. It's called the constant rule. Okay, so if I have a function that is just a constant, there's no x's associated with it at all, then what's the derivative of that function? Well, let's go back to our definition of what the derivative is, and there it is. F of x plus h is going to be c, and f of x is also going to be c, because no matter what you plug in for x, the y value is always the same constant. So on the top of that fraction, I have c minus c, which is 0, and I really don't even need to worry about letting h equal 0, because that is going to be 0 no matter what. All right, so no matter what the constant is, the derivative of that is going to be 0. So if my function is 23, the derivative is 0. If the function is negative 19, then the derivative is 0. If the function is 0.47, then the derivative is 0. If the function is e, then the derivative is 0, because e is still a constant. All right, so there's that rule. Then there's the constant multiple rule, where if I have a function that is a constant multiplied by a simpler function, then what's the derivative of that? How does the derivative change? Well, there's my definition again. And so I can rewrite f of x plus h as c times g of x plus h, and f of x is c times g of x. And what I notice is that there's a common factor in the numerator of that c, and it's not dependent on h, so I can factor it out and actually pull it outside of the limit itself. And so what I'm left with is c times something that looks very, very familiar to the definition of the derivative, except it's got g's instead of f's. So what I have is I have c times the derivative of the g function. So if a function is being multiplied by a constant to get a new function, then you just take that derivative and multiply it by the same constant to get the new derivative. Let's go over some examples of that. I knew that the derivative of x squared was 2x, so the derivative of 4x squared is going to be 4 times 2x, which is 8x. Similarly, if the function is negative 9x to the third, then the derivative is negative 27x squared. If the function is 5 times x to the 0.2, then the derivative is x to the negative 0.8. Okay, so some examples of that. Adding and subtracting, there's a rule for that. So if I have a function that is composed of two functions being added together, what's the derivative of that? So I go back to my definition. F of x plus h is just going to be p of x plus h plus q of x plus h. And then if I subtract off f of x, I'm subtracting pq and I'm subtracting q of x, and all of that goes over h. So that can be split up into two limits, both of which look like the definition that I started out with, using different letters as my functions. So it's going to be p prime plus q prime. So if two functions are being added together and you want the derivative, you just take the derivative of each function that is being added or subtracted. Okay? All right. So for example, if I have a function that is x to the fifth plus x squared, I can take the derivative of each of those separately, and that will be the derivative of the whole thing. So f prime will be 5x to the fourth plus 2x. If I have a function that is 5x to the 9 plus 12x squared, the derivative of that is going to be 45x to the 8 plus 24x. And if I have f of x equals 8x to the 1.5 minus e to the 4, then f prime will be 12 times x to the 0.5. Notice that I don't follow the power rule for e to the fourth because e is actually a constant. That rule only works if your base is a variable, not a constant like e. So don't be tricked or fooled by that. All right, now when we're talking about multiplying and dividing, it is not so simple. There are going to be some rules that we learn that talk about how to handle a function that is composed of two smaller functions being multiplied together or divided. So please don't try and make up your own rules for that. If you have a function that is made up of two functions multiplied together, the derivative is not the derivatives multiplied together. Same thing for division. If a function is made up of two functions being divided, then the derivative is not the quotient of those two individual derivatives. Okay? Also, there's separate rules for when variables appear in the exponent rather than in the base. So don't try and make up your own rules for that. We will learn those rules. So if instead of x to the fifth, I have 5 to the x, I can't follow that same rule and come up with something like x times 5 to the x minus 1. Similarly, if I have e to the x, I can't treat that like x to the e and come up with some function that follows a rule that actually doesn't apply. Okay, but we will go over those rules eventually in this chapter, but for now, those are the rules you need to know. If you have any questions, please let me know, and I will see you tomorrow.